Don't hog your Angular code. Share it between web and mobile. So that's what this talk is about, sharing your code. We have a new project. This is excellent. You got a new project assigned and you're ready to take it on. Your client, facenote.com, they want to modernize the way they collect user personal data. Currently, the Facenote team, what they do is they travel around the world collecting users' private data by hand. They write it down on a piece of paper, then they go back to the office, then they input it into Excel, and they generate reports. So what they want to do, they've asked you to do a digital transformation of this entire process to help them out. They want these three things. They want a web application, they want an iOS mobile application, and an Android application. Pretty typical, right? So to accommodate their request, we used to do things this Stone Age way, I'm going to call it. I'm going to take the risk and call it that. Some people still do it this way, but there's better ways, and that's what we're here to talk about. So for the web, they're going to go ahead and design, develop, test, deploy, maintain, and manage that whole stack. And the whole team is going to do it just for web. Then we're going to have a separate team doing this for iOS. The same process, design, develop, test, deploy, maintain, manage. And we're going to have another team that's going to do their own thing. Well, the same thing really, but in a separate silo. I'm going to call these silos, we can go with a theme and call it sties, but they're separate and they're kept separate. So each team, they're going to hog their code. Maybe they'll share if they're really nice. What do we do these days? What can we do these days to improve this process? We can do all these steps, but we can do something called code sharing, which sounds better than code hogging, doesn't it? So who is happy in the end when we do all these steps in one silo instead of 3 silos? Facenote.com is going to be happy, your client. You're going to be happy because the client is going to keep coming back to you for more projects. Developers are going to be happy because it's easier for them to maintain this stuff. It's easier for them to implement new features. They can do it across the board. Everybody's happy. But you might ask, why should you care about native? Who cares about native? You can just do a responsive web application or a PWA. Why not create one of those, right? Well, there's been some studies done, and years of usage data tell us that native and web each have their own unique advantages. Native is known for having performance experience that's better, a rich experience. And they tell us that people use native apps, and the amount of time that they spend is through the roof. It's much higher than web applications. What about web? Web is also available, and it's known for its reach. It has a very wide reach. It's available to all devices. It's available to all operating systems. It's not limited to any of those. Web apps run everywhere. They're a good way to reach a large number of people, diverse populations, and so on. So they're also very good. I like this quote a lot by Luke Wroblewski. The web is for audience reach, and native apps are for rich experiences. Both are strategic, both are valuable. So when it comes to mobile, it's not web versus native. It's both. You need both. Next question is, how is this possible? Is it possible to create an app for all platforms while reusing as much code as possible and still get great native performance on the mobile apps? Well, yes, it is possible. That's why we're here, right? So to accomplish code sharing, we use Angular together with NativeScript. Angular provides the web piece and the code sharing friendly architecture, while NativeScript gives us the building blocks to cover iOS and Android. So we'll go into that a little bit more. Who here has used NativeScript? I know some people have. Anybody use NativeScript already? No? Okay. Well, I'll introduce it to you then briefly. NativeScript is a cross-platform framework. So you create, it's designed to be cross-platform, so for iOS and Android. It lets you create native apps and I'll show you what I mean by that, by native. Using a single code base, you can write your apps in JavaScript or TypeScript and CSS. So technologies that web developers are going to be familiar with. Anybody here use Xamarin before? Okay, Xamarin is another framework to create mobile applications, but this time using C# and that whole ecosystem, the Microsoft.NET ecosystem. Anybody here use React Native? We have one React Native person. All right. So NativeScript is similar to React Native, except for the framework, you don't use the React framework for the UI framework. With NativeScript, you can write either using no framework at all, just pure JavaScript code or TypeScript code, or you can use Angular, or you can use Vue. So it's everything that, it's a JavaScript application, everything that React is not, the opposite. The end result, both give you native applications. Now, are there any Cordova or PhoneGap people here? One person, okay. So NativeScript is not at all like PhoneGap or Cordova. Instead of using a web view for rendering your web application inside a web view, NativeScript gives you fully native user interfaces. So all the elements you use get transformed in real time into native equivalents. And the UI that you see is native instead of a web view. That's the difference. With NativeScript, you also get zero-day access to native APIs. So for example, if anybody saw the keynote today, there might be some native APIs. Actually, they don't talk about that. They talk about WWDC, about new APIs, but you know what I mean. Let's say the new hot API comes out for iOS, and you want to use that same day, you'll be able to in JavaScript using NativeScript. So that's a quick intro for NativeScript for those that haven't heard of it before. The main way to use NativeScript, to interact with it, is using the NativeScript CLI. It works with the existing mobile development tools such as Xcode and Android Studio. And with version 5, which is coming out next month, there's going to be a new way to work with it. So I can talk to you about that later, but it's not related to this talk. And since setting up a mobile dev environment is sometimes a little bit daunting for people that are new, like this crowd here doesn't do much mobile dev. So how do you get started really quickly? There's 2 tools available for that. One is called the NativeScript Playground. Basically, you drag and drop your UI in a browser. And then you scan a barcode using your phone, and you can develop in real time a native application using just the browser. Another tool is called Sidekick. So this is a tool that also helps you out. It does a lot of things. But what it's really famous for is if you're working on Windows or Linux and you don't have a Mac, you can do your builds in the cloud. So you can build for iOS in the cloud. Let's go back to code sharing, which is why we're here. What does code sharing mean? How is it good? And how to prevent us from hogging our code? Code sharing has its roots in the DRY principles of software development. You've all probably heard of DRY. Don't repeat yourself. Something we always strive to do when we architect our code. We want to write our code once and not have lots of different copies to maintain all over the place. So when FaceNote.com, for example, wants to have a web app and 2 mobile apps, we can do it the old way, where we write the web app and we carefully abstract away all the business logic into separate libraries, thinking it's good to keep as a separate layer. And this is true, it is good to abstract that stuff, but it doesn't go quite far enough because we have to copy this code, reuse it in our mobile apps, and it's just hacky. There's many frameworks that are trying to solve this problem. NativeScript solved part of the problem when they first came out. The very idea behind it was code sharing between iOS and Android. But the web sharing has always been a little bit hacky for all these years until recently. So we've been sharing code by manually copying business logic, but that only takes us so far. And who here likes to copy code manually? Anybody? Yeah, I didn't think anybody was going to raise their hand for that one. So maybe you've written a script that does the copying for you, and that's how we've solved this a lot of times. That's great. But yet, that's another script to maintain, right? We have to maintain that script when things change and things get just messy. Who's going to do it, right? That one girl or guy in the back that does the script, they leave, and then nobody knows what happened. And then we end up copying code again. Is there a better way? Wouldn't it be great if this was automated for you? If you didn't have to care or maintain a script? I'm so glad you asked me that. There are a few ways to share the code. All these have to do with the CLI. So let me go to the approaches now of how we can do this and how we've done this in the past. Now, since NativeScript is an open source project, there are many open source code sharing solutions that have popped up to help us automate the process of sharing code. Here are some examples that we've used in the past before the official solutions were available. So people have created these things called seeds. They're up on GitHub. You can clone a seed, which is just a project structure, and it has some scripts associated with it that you run, which do some of this automation for you. A big one was the Angular Seed Advanced by a community member, Nathan Walker. It's one of the original ones that came out to do this. It's very difficult to use, though, for newbies, and it has a lot of functions, but it's not going to be maintained for too long. Here's another one. This one was really simple. This is also by community members, but it doesn't offer much power, although this one was really easy to get going with. I don't think that one's going to be maintained either. So let's get to what's new and what's now. NX Workspaces. Have you heard of NX Workspaces? Anybody? So this is a relatively new approach for Angular applications in the enterprise. Basically what it does is it provides enterprise Angular apps with a proven structure that works and using standards and patterns. And it's a pretty robust approach to code sharing. NX stands for Narwhal Extensions for Angular. We won't cover the approach here, but it's actively and successfully being used in the enterprise today. For those of you that went to ngConf this year, anybody else? I know Alex went. So there's a tool that was announced called XPlat. Stands for cross-platform. So this tool is distributed via Angular schematics to provide easy setup for code sharing development scenarios. It supports web, iOS, Android, some other platforms, and soon to support Electron and server-side rendering too. So it's a really good general tool to use for cross-platform and code sharing. Wouldn't it be awesome, though, if we could use the Angular CLI to do code generation and Webpack to perform automatic code splitting for us? How many people here use the Angular CLI? Nice. Okay, so you're familiar with it. We're going to see some of that later. Before Angular version 6.1.0 and NativeScript version 4, if you wanted a native app and a mobile app, you could have used one of the code sharing approaches I showed you before, or you could have done the Stone Age way. But now, after these versions came out, there's a new way. So recently things have changed with schematics and ng-add as part of the Angular CLI. So the Angular and NativeScript teams, they got together to create this thing called NativeScript Schematics. So this is a collection of schematics that enables you to build both Angular web and Angular native mobile apps from a single project, and thus achieving code sharing. So let's take a look at a quick demo to begin with. I'm going to have another demo later on. So we need to start off with the Angular CLI and NativeScript schematics. I've already downloaded and installed the NativeScript CLI. I already have that on my machine. So I'm just going to go and update my Angular CLI. So I'm going to install that globally. version 6.2.1 as of today. So that's pretty fresh. Okay, I'm also going to install the NativeScript schematics just to show you what the steps are. Also, global installation. Pretty simple. Okay, so ng new to create a new project. We're going to pass in the collection using NativeScript schematics. So we're going to kick off a new project. We're going to give it a name called Web Mobile, and I'm going to use the shared flag. So this will generate a brand new project with both Angular Web and Angular Native in it. I'm going to go into the project directory and open it up in Visual Studio Code as my editor. Okay, so here we go. You can see the project structure is pretty familiar to those that have done Angular development. Here we have Webpack config. It has dependencies for Angular and for NativeScript. Our package.json file has both, everything up to date. Yep, Karma for testing. Okay, then we take a look at the source code. There's our main.ts. We also have a main ns.ts, which is for NativeScript. I'll talk about that later, why they're two separate files. And here's our main app directory for all our code. Okay, we have app component.ts, which is the shared component. So this is for both native and web. Pretty familiar, right? Nothing very different here. So you'll see two app component markup files. One is HTML, and one is for NativeScript. They're a little bit different, and I'll talk about the differences later. But you can see that they're named a little bit differently too. However, the main component.ts file is the same for both. The only difference is the two markup files. Let's run this. ng-serve will spin up a new server, and this will start up the web application. There's a web application, pretty simple. We have a H1, we have a logo, and some links. Okay, I'm going to pop open a new tab, and I'm going to kick off the NativeScript. Using the NativeScript CLI, I'm going to build for iOS using the same project. So there's my iOS simulator, and it's going to start my app, my native app. Here we have welcome to Web Mobile. Web Mobile is just the name of the project. You can see it here too in the web project. And that's data bound, that title is data bound in the code. So you can see on the native side, we have a label, data bound to title. And in the web side, we have a label data bound to title also. And here's where we set the title in the code. I'm going to go ahead and change it from Web Mobile to Alex's app. Prettier is changing my quotes. Anybody use Prettier? I like that tool. All right, so here's Alex's app. As you can see, it's updated now. Let's do something else. Let's change the color of it. And the color can be controlled through CSS, regular CSS. So I'm going to open up the CSS file that's also shared. I'm going to create a new rule with the color red. Let's copy that class name. And I'm going to apply the class name to that H1 at the top. There's my web project. It has a regular H1. And my native project, my iOS project, has a label with some class names already there, so I'm just going to add this class name to that list. Okay, there it is. It's in red on both, and it automatically updated. So let's do something else. Let's see how code will execute in the code behind. I'm going to add a button, and I'm going to add a click event. And this button is in the web version in the HTML. I'm going to go ahead and copy that, and I'm going to paste it into my native markup, but in native you don't have a click, you have a tap. So I'm going to change that handler name. And we also don't have inline text in native code. We have a text property on the button. So I'm just going to drag that over. Now we need to implement this on-button click event, and we're going to have one handler for this. This is the shared handler. And we're just going to pop up an alert that says button activated. Come on, Alex, type faster. Let's see. This automatically is live syncing to the application. There's our little button. When you click it, it says button activated on the web. And there it is in my iOS device, button activated. Pretty cool. So you saw an example of starting out with code sharing. You can see that we can share code, we can share services, we can share CSS, and I'll talk more about what we can share. How is this possible? Now I mentioned that Angular is the primary driving force that allows you to do this kind of code sharing. Let's get into the nitty-gritty of how this actually works. First of all, Angular supports data binding and event binding, a mechanism for hooking up parts of a template, which is your markup, to parts of the component, which is your code. It comes with binding markup that tells the app how to connect both property bindings and event bindings. Additionally, Angular abstracts away the renderer itself, making our components and the templating language platform agnostic. So components imperatively interact with the renderer. Angular uses the renderer to set up host listeners and host bindings. Renderer communicates with the DOM, for example, by calling doc.createElement, and DOM returns you the element, and in the end we get an application rendered to the screen that the users can interact with. On the other end, we have NativeScript. How does NativeScript do the same thing? NativeScript provides its own implementation of the renderer. Instead of communicating with the DOM, there is no DOM in native mobile UI, right? So the renderer communicates with the mobile UI layer, which NativeScript provides, with the final outcome being a native mobile app. And as a result, we have access to the same components and same templates from the native mobile app. So here's an example of a component. Let's build this up from scratch. It's going to be simpler to see that way. So we have a component. It has a couple of properties on it. It has an event. Let's take a look at the markup that we would bind to that component. This is an example of a web template markup. You can see it has a couple of divs, a span, a button, a click handler. Very simple. Here's an example of a native template markup. There is no div. We have a stack layout instead, because we want to specify how we want that displayed. And instead of spans, we're going to use labels. Instead of a button, we're going to use a button. I shouldn't have said that. You know what I mean. So there are a few differences. For example, button has a click here. Here, button has a tap. We can do in the web. Browsers are very forgiving in how we display and how we write our HTML. So there is such a thing as a text node. In native, there is no text node, so you have to specify text as an attribute of the button. Same thing for labels. So what else can we do? Well, Angular also provides us with a dependency injection mechanism, which can be used to provide web or mobile specific modules and services. So we can get specific. Here's an example that's more concrete. The way HTTP works in mobile is different than the HTTP, the way it works in the browser. As a result, in a web project, we provide an HTTP client module in the ng module. There's HTTP client module. We're grabbing it from Angular, and we're importing it in our ng module. This is for our web app module. Now for NativeScript, we provide the NativeScript HTTP client module. And that's coming from NativeScript Angular package. So same idea, but we're providing a different HTTP module, and that's why we have two different app modules. I'll show you that in the code later. What's the result? The result is we use HTTP client in any of our services like we did before, and we don't care about whether we're on the web or whether we're on mobile. We just use it. So here's my HTTP service. This is shared code right here. All we're doing is injecting HTTP client, but it knows that if we're on the web, we're going to use the web one. If we're on native, we're going to use the NativeScript one. Okay, there's our get data call, and we're just using HTTP client. So that's what Angular brings to the table. Pretty cool. Now, to get web and mobile working together in one code base, some of the tools I mentioned earlier, they used a custom build process, some of the seeds that I mentioned. So we used a combination of these tools. That was the old way of doing it. This was good, and it's something you didn't have to maintain yourself, but it had its limitations. With the new CLI approach, the Angular CLI team and the NativeScript CLI team, they synchronized the new build process. This time they're going to use Webpack, well they are using Webpack, and a set of loaders together with it. Webpack is pretty much a standard way to do code splitting and bundling of your front-end code at this point. Remember I said we'll come back to this. So what can be shared? Here are all the things that can be shared. This is pretty cool. We can share all our services. We can share our pipes, directives, routing, components, and even SAS variables. SAS variables, sorry. Why am I not saying CSS over here? Why am I saying SAS? Because SAS is designed in such a way where you can have variables, and variables can easily be shared. CSS, though, has its limitations. For example, there are some things you can't do with CSS that are shareable, and I'll talk about that in a second. So what is different? Well, as you saw, markup is really different. It cannot be shared at all. That's one thing where you have to write a different markup. Anything markup related. So, for example, when you have a CSS file, or you have CSS defined, your class is defined, I shouldn't say classes, rules, your CSS rules. And if your rules are targeting specific elements, some of those might not be shareable. If your rule is targeting a div for the web, there's no div in native. If your rule is targeting a stack layout or a label in native, there is no such thing in web. What is different? Anything else you want. That's a pretty weird statement, right? What do I mean by that? Anything else you want? What do I mean by that? So, code splitting is something that we're capable of doing now automatically using naming conventions. So, let's say you have a file that's specific, that you want to be specific. Sure, you can share your TS code, you can share your TypeScript code and your JavaScript code for your components, but what if I really want a separate file to execute for my iOS or for my Android devices or for my web devices? Well, you can do that, and that's what I mean by anything else you want. By using naming conventions, you can do code splitting, and you can name your files in such a way that will allow you to target specific platforms. Let's take a look at another demo. This is where we left off last time. So we have a little clicker there. You saw this already. Button activated. Great. So what I want to do is I want to extend this demo a little bit. I'm going to use third-party charting library, but two different ones, one for web and one for native. So I'm just going to paste in a Kendo chart, which is just a charting library, third party. And it's going to be bound to categorical source. You'll see what that is in a minute. And in my native markup, I'm also going to paste a rad Cartesian chart, another third-party charting library. This one is bound to the same exact data source in the code, categorical source. So let's go to our component. I'm going to create a categorical source, which is just an array. It's a JavaScript array. And we're binding, in both instances, we're binding to that array. Right now it's empty because that array doesn't have any items in it. So let's do this. Let's create a services folder, and I'm going to simulate fetching objects. I'm going to create a myDataService, which is an Angular service. So I'm going to use snippets to create an injectable service. I'm going to call it myDataService. And here I'm just going to hard code a bunch of objects. Countries and some values. Okay, so it's just a static list of objects. All right, I'm going to go ahead and inject that service into my constructor in the component so I can use it. And when I initialize my component, I'm going to set the local categorical source array to pull from that myDataService. Basically, it's just a way to get the data, to simulate fetching the data from another place. Cool. So now my data service needs to be registered, right? It needs to be registered as a provider. And remember when I mentioned we have two different modules for code splitting? I'm going to register it as a provider in my web app module and in my NativeScript app module, which has a .tns extension. That's that convention that we use. Okay, there we go. So now we have that data set displayed as charts in both libraries. They look different, yes. The one on the right is native, so it's all native components. The one on the left is web. So just to prove to you that this is working and it's live syncing, well, it's not live syncing, it's a video, but you know what I mean. I'm going to add another country, Canada, and I'm going to give it some big amount, 300, just so it sticks out. Okay, there it is, live syncing, and we have that data in the chart now. So we're using the same data source, we're using the same component, two different markups. So what I wanted to do is just, I don't know, for the heck of it, I wanted to perform an experiment. I wanted to see how many lines of application code can be shared and converted to a percentage from this simple little application that I created. Counting lines of code is not exactly something that's accepted these days, but what the heck. So what I got was, in this little application, I had a total of 228 lines of code. Platform-specific code was only 29 lines. So if we converted that to a percentage, 87.3. So typically, there is about 60 to 80% code reuse in real-world apps using these scenarios, and that's huge, right? So we know code sharing is good for us, and especially for our client FaceNote.com, so they can collect more personal user data more efficiently. But why is the newest CLI approach so good? Well, it's built on standards. It's built into existing CLI workflows. Those of us using CLI already know these workflows. We can just keep using it. And you don't have to maintain it separately. And finally, I just wanted to say thanks to all those who didn't shove themselves in a bunker tonight, afraid of the thunderstorm. Thanks for coming out. Also, as a token of thanks, I have a school that I run called NativeScripting. If anybody came out here and they want to use this code to get discounts on your courses, video courses. That's it. Thanks for coming out, folks. Also, don't forget to grab your swag. If anybody has any questions, come and talk to me.